Lehman College's Matt O'Dowd is developing new methods for studying the structure and evolution of the universe. Black holes, quasars, and dark energy. Reporting from Earth, here's Lisa Beth Kovitz.
Back in the days of Copernicus, an astronomer just needed a telescope, a bit of parchment, and some math. But fast forward to the days of Matt O'Dowd, and to really understand quasars, an astronomer needs a huge new grant from Eric and Wendy Schmidt's foundation, Schmidt Futures. Plus, a little bit of AI.
The days when we would look at individual objects through our telescopes are almost gone. And part of how we try to understand the universe is to seek patterns. And the patterns that are in these data don't fit on any parchment.
Okay, so what's a quasar?
Quasars, which are easily my favorite object in the universe, are what happens when the largest black holes in existence start to feed. Normally they're black, they're dark, but when they start absorbing material, you get this screaming vortex of superheated matter piling into the black hole, and that thing glows bright. You can see these things to the ends of the universe.
But lucky for us, these feeding black holes are really very far away.
So far away, in fact, there is no telescope that we could build in the foreseeable future that would be able to take a photograph of the inside of a quasar.
But when other galaxies pass between us and a quasar, Einstein's theory of general relativity kicks in, and the light emanating from the quasar bends.
As its light is bent around that galaxy, you might see 2 or even 4 images of the same quasar in a pattern. Now, those images flicker, and they flicker because the galaxy itself is actually a pretty bad lens. It's made up of many stars, and those stars have their own gravitational fields, and as the two pass by each other, the stars cause different images of that quasar to flicker in different ways. And so you have this kind of radar sweep, which allows you to actually map the inner structure of the quasar.
But recognizing patterns in such a giant heap of data requires math skills beyond the scope of any human being.
Let's think about how Nicholas Copernicus figured out that the sun was at the center of the solar system. He guessed some equations, wrote down some math, and found that the math predicted reality. This doesn't work when we're talking about not one star, as Copernicus had to deal with, but thousands or millions of stars. The result is just too messy to be represented by a single equation. And so what we need to do is train these artificial intelligence algorithms to look for patterns that we wouldn't think to look for in these data.
And will this grant change Lehman College?
Lehman College is already world-class in quite a number of areas of research, and shout out to the physics and astronomy department. I think what this grant does is it brings me a bit closer to the league of some of my colleagues there. It's definitely an opportunity. It's a big international project. We have collaborators from around the world. It will also, I think, amazing for students.
Matt, could you give us a glimpse into your world that might make our stargazing more exciting?
I still look up at the sky and find stuff amazing. I think people worry that studying these things might jade you. If you know how stars work, stars become less magical, but it's not true. I think the universe becomes more magical the more you learn about it, because the more you learn about it, the weirder you realize it actually is. The awesomeness of stars, of galaxies, many scientists feel like we're standing above this strange knowledge that is yet to be found, and how weird is the universe going to seem as we start to learn more and more. It's an awe-inspiring journey, for sure, and I would certainly encourage everyone to learn a little more. Every little bit of knowledge, I think, increases the wonder.
Matt, thank you so much for spending time with us.
My pleasure, Lisa, as always.
This has been Lisa Beth Kovitz for Simply Science.